Good morning, folks. I'm Levent Besik, Director of Product for Cloud AI Business and Developer Solutions. Super excited to be here today. Thanks for coming and joining us here at Excel. Today, I'd like to give you a quick overview of our Cloud AI product portfolio. And more importantly, actually, we're going to have three of our customers come join me on the stage and do a deeper dive into their use cases and talk about how they were using our products to add real value into their businesses. So let's get going. So I should probably say that your feedback is greatly appreciated, so please make sure to fill up your surveys after this. A quick recap of our mission. Our mission as Cloud AI is to empower every enterprise to transform their business with artificial intelligence. We believe that machine learning is a fundamental new technology that's going to revolutionize everything in the enterprise, and we want to make sure it's accessible to every business around the world. And to that end, we've been very busy. We've been working on our products to make sure that it's a comprehensive suite that meets all the needs of our customers. And just this year, we launched 60+ products and features on our portfolio, serving 26 verticals, because we believe that those vertical context-aware use cases and those products are really important to really add business value. And on top of that, of course, we want to make sure that we have a strong ecosystem of partners so you never feel alone in your AI ML journey. Last but not least, we have still a deep and continuous connection to our data science community within and outside of Google through Kaggle, which today has more than 3.5 million members. So really excited and proud of that. All right. So as I mentioned, customers come to us to use ML in varying levels of needs and requirements. And what we find out is that in order to be a powerful platform, we need to serve each of these needs. And how we do that is that we provide different levels of abstraction, layers of abstraction of our products for anyone that might need a specific use case. So on the very top here, we have our solutions. And these AI solutions are basically plug and play, ready to go with our partners so that you can have immediate business value for your specific use case and for your specific workflow without a deep investment of any kind into machine learning. One level below that is our APIs and AutoML, which is primarily geared towards our developer friends. And again, here, you don't have to be a machine learning expert, but you can still have access to some of the best-in-class tools and APIs for either with pre-trained APIs or with customizable tools like AutoML to create a specific model for your needs. And underneath that is, of course, our powerful AI platform. It's a robust and reliable platform for data scientists primarily, who wants to create their own models, iterate on them, collaborate with their colleagues, and of course deploy them successfully. And all of this, of course, is built on top of our purpose-built infrastructure with GPUs and TPUs to make sure you get the best efficient performance out of it. So I'm going to go through these one by one, starting with our solutions. And I want to actually specifically touch on contact center AI. So one thing that we see quite often, especially from our B2C customers, is that they often have this really growing pain in their call centers where they face a trade-off between operational efficiency and efficacy and great, excellent customer service. Well, with the advances in language and conversational AI, that doesn't have to be the case anymore. And with contact center AI, we basically want to solve this problem primarily in three levels. First, with our virtual agent product, we want to contain your incoming calls and chat conversations as efficiently and as reliably as possible, leading to happier and quicker customer outcomes. And if for some reason we cannot contain those calls, we want to make sure that we empower your agents in real time with turn-by-turn directions, with suggestions, and also mapping your entire corpus of knowledge in your enterprise to their fingertips so that they can quickly resolve the customer issue and leading to better agent outcomes and better customer happiness. And finally, we want to give you tools so that you can see what's happening in your call center, with our call center analytic tools such as Topic Modeler. So you can see what's happening, you can optimize for it, and you can feed that back into your call center. Now, I want to quickly invite Akash Parmar to stage, who's going to talk more about how they were able to use technologies in Marks & Spencer for better outcomes. Akash. Thank you.
Just this one. Yeah. Morning, everyone. I'm Akash Parmar. I'm an enterprise architect at Marks & Spencer. Established in 1884, Marks & Spencer is one of British leading retailer selling home, clothing, and food items in over 1,400 stores across 57 countries and through our 50 international websites. Marks & Spencer is undergoing a 5-year transformation plan. Everyone in the company is working towards restoring the basics, shaping the future, and making Marks & Spencer special again. So what does that mean to the customer care team I work with in Marks & Spencer? This means we have to provide the best customer experience to every caller, be it our colleague or our customer, and make sure their experience is memorable. So one of the big challenges we had was how do we effectively manage 14 million calls which come into our contact center, stores, and head office. In the past, these calls were managed by completely different platforms with their own IVRs, with their own routing and reporting solution, and it was expensive, plus the experience across them was very, very inconsistent. So if you as a customer, you think it's Marks & Spencer, but if you call a contact center, you will have a completely different experience compared to what you'll get in the store. So a very typical store experience. So if you had called the store maybe 18 months to 2 years ago, you'll go to the website, you'll pick up the store number of your local store, you give a call, you'll get an IVR, it'll say press 1 for opening hours, dial an extension, press 2, and after going through this IVR, you probably press an option to speak to someone. First person you'll get is somebody on the switchboard. They'll try and send you to an extension in store. Most of the time, it will just ring, 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 because the colleague in store is busy dealing with the customer who's actually walked into the store. The call will bounce back to the switchboard. The switchboard will try another extension. This will go in loop till either the customer gets frustrated and hangs up, or if you were lucky enough to get the call answered, you might and have a query like buying something. The store colleague will have to then transfer the call to the contact center. So a very, very inconsistent experience. The problem was very clear. An IVR, which you have to press 1 or 2, cannot really capture hundreds of reasons why a customer is calling us. And then the fact that we were sending a lot of calls to stores which they couldn't even service. So we had to come up with a solution. When we thought about this, a very obvious and a very clear solution was, why don't we just let the customer say in their own words why they are calling? We then understand what they're saying. We find an intent. We try and self-serve using automation. If we can't, we send them to the right place first time. So here's what we came up with. We call this platform Ava, Automated Voice Assistant. The fact that Ava is the name of our manager's granddaughter had got nothing to do with this, so just to make sure. And so how does this work? So we moved the entry point of all our stores and contact center calls onto the Twilio platform. It's a CPaaS platform using which you can pretty much talk to any APIs you like to. This gave us complete control of our calls. So now what happens is a call comes in. We created an orchestration layer which was within our secure MNS network. So call comes in. We take over the control of the call. We ask the customer, please, can you tell us why you're calling? They leave an utterance. And then Google Speech API transcribes that utterance for us. We take the text back, pass it to Dialogflow. Dialogflow will then return an intent. At this point, we'll try and either do some automation. And if we can't, we'll have a destination where we can route the call to either the contact center or to the stores. So we use the text-to-speech API, which was very, very useful to make it sound very, very human-like and not too robotic. and some light integration with our existing Genesis and Mitel solutions in stores and contact center. Overall, it proved to be a big success. And one of the things which we learned, so as you can see, the journey was very, very simplified going forward. What happened here was we reduced calls to store by 50% because they would either self-serve, they will go out, or they would go to the contact center. We also replaced the DTMF IVR with natural language, and this allowed over 100 colleagues who were busy taking the calls in the background to be on the shop floor dealing with the customers. This was a really great experience to go through, and one of the things which we learned was not to get bogged down into making everything 100% accurate. You need to let different AI complement each other and work with each other. So in our early days, we were getting some transcriptions from the speech API, which were not what we expected. It was not word by word what we expected, and we had to kind of train the model to make sense of it. So I've got a few examples of these transcriptions, which were not word by word, which makes any sense within MNS. Have a guess and see whether you can guess what it means within the MNS world. So Jamaican order, we were like, do we sell Jamaican food? What kind of Jamaican food we sell? We are getting thousands of calls about it. It was actually customers calling to make an order. And then we just place that into the place order intent. It goes to the contact center. Next time any Jamaican order comes, it goes to the contact center. We started to get calls about Brad Pitt. I'm like, we've really won the Oscar here. Brad Pitt is calling us. This was not actually Brad Pitt. This was call about Brafit, which it's a big business for MNS, and we had to send these calls to the Brafit section in store. So next time Brad Pitt calls up, you know where he's going to go. This one here, I did say we want to provide the best experience, but we have to draw a line somewhere. But this was a colleague calling to find out about their hours, and they had to speak to the ops manager to find out when they are working. So just to see, you have to play with these. And it's not the old world where you have to be accurate about everything. Just let different AI work together, and as long as you get what you want out of it, it's perfect. So experimentation, rapid experimentation is the best advice I can give. Some quick stats around it. So this proved to be very, very successful. We have now, so initially we saw customers calling in, and there are lots of calls where they were just hanging up the call, and we're like, why are we getting these abandoned calls? And then we saw those customers were calling back again, and we've worked out the customers were not used to kind of saying something as soon as they call. They were waiting for this, press 1, press 2, and then press something, and suddenly they have to speak. And then they're like, OK, I don't know what to do. Hang up the call. And then they call up again, and they're like, oh, yeah, I want this, I want that. So over time, now, 92% of the calls, when they come in, the customer leave a good utterance for us. The transcription rate using the speech APIs, Google Speech APIs, is really, really good. Now we no more bother about getting it 100% correct as well. We just train the model and then just take it from there. The intent model has matured over time. So now almost 92% of the calls are assigned to the right intent. In the contact centers, we got rid of reason for contact because we just put the intent as the reason for contact because that is exactly what the customer called about, and we know that in their own words. Overall, a very positive experience from the customers. Oops. It's future use cases. So we have, as you can see, we created a platform which not only solved a problem, but it also opened up opportunities for the future. So now we know what the customer is calling us about. We understand it. What we have to do now is to fix the problem, solve the problem for the customer. So we want to do that through automation, personalized self-service. We want to also create channels where the customer, omni-channel, where the customer can just call in or get in touch with us using any channel they like. Because now we have the brain, pretty much what I call it, you can not just push voice through it, you can push SMS, chat, WhatsApp. Any channel can go in and come out with an actionable intent. And overall, I mean, I wish Google had come up with the contact center AI 18 months ago, because that would have made our life a lot more simpler. We are looking forward to experimenting with the new cloud AI features to make every contact our customer has with MNS truly special. Thank you very much.
Thank you. Thank you, Akash. All right, that was great to hear about their success story. So next up, I want to talk a little bit about our developer building blocks. And here I'm referring to, of course, our pre-trained APIs as well as AutoML. So our goal here is very simple. We want to provide a comprehensive set of capabilities across 4 major domains: site, language, conversation, and structured data, to developers so that they can easily use the latest and greatest in ML development and technology in their applications and services and add that layer of intelligence for their purposes. And we do that primarily through either our pre-trained APIs, which are simple APIs that you can just call from your applications or services, no ML knowledge needed, using Google's data, of course, to train those APIs for common use cases. Or if you have a custom specific need that needs a custom machine learning model, we, of course, have our AutoML suite of products that allow you to customize these APIs with your own data. And the great thing about these capabilities is that as Google, once we release them, we don't forget about them. We continuously drive new improvements into those APIs. So for instance, the speech API continuously gets better and better. You don't have to do anything. We just retrain our models and get those accuracies up over time. And we, of course, continue to release new products. And as part of that, I'm actually very thrilled to announce here today that as of today, we have 3 new products available for general availability for your use: AutoML Vision, as well as AutoML Translation, and AutoML Cloud Translation API. So I can't wait to see what you guys will do with those APIs and AutoML capabilities. Now, one thing I want to double-click a little bit deeper on is AutoML natural language, since we see a lot of excitement around this feature. Basically, AutoML natural language allows you to create your own custom machine learning model for classification, for sentiment analysis, and for entity extraction. And the experience is pretty smooth. It's primarily a UI-driven experience, although we do have APIs. If you prefer APIs, we don't discriminate. But in our UI, all you have to do is just upload your documents, your text snippets. AutoML on the back end trains multiple models, deploys some of the latest technologies that's available to us, multiple architectural types, feature engineering, whatnot, picks the best one. You get to evaluate which one you like the most, or you can just deploy the best one that AutoML picked, and you can actually just deploy it immediately to a REST API that's ready to scale, period. So all of this is done through a UI-driven experience with no deep knowledge of ML needed. So we're, of course, really excited about this, but I actually want to now invite Dan Gilbert up on stage, who's going to talk a little bit more about how they use these capabilities and use use cases. Dan.
Great. Thank you, Levent. Thank you. My name's Dan. I head up the team of machine learning engineers and data scientists at News UK. We are a media publisher. Most of you have probably heard of us. So we publish titles like The Times, The Sun, Sunday Times, TLS. We also include the wireless radio groups, so it includes stations such as Virgin. And much like Akash and Marks and Spencer, the Times is like an old publication. It's been around for more than 200 years. And one of our roles is to kind of guide the world and the UK through kind of an increasingly confusing time in terms of politics and news and what is happening. And increasingly, a lot of the content that we produce, and we produce a lot of content, so it's always tricky to put your finger on a number, but somewhere between 250,000 and 500,000 pieces of content per year we produce across our titles. And more of that is produced and served and reaches audience online rather than through print. And as such, we've gone through a digital transformation, and much of that digital transformation has been accompanied with machine learning, and the rise since kind of 10 or so years ago has helped us build better knowledge about our customers, how they behave, what features of the product they enjoy, how to improve the customer experience. But despite that, a lot of the benefits we've gotten has been through kind of big data analytics on things like BigQuery. A lot of the advances from deep learning in terms of things like image recognition have not really helped kind of transformed our business. I think the real exception is natural language processing, and much like deep learning and image classification kind of 7 or 8 years ago was going through kind of a moment of massive change. We're really in a kind of golden age of natural language processing in terms of the ability to use machines and data to understand the semantic meaning of text. And as a news publisher, we produce a lot of text, so this is incredibly interesting to us. And we use it for a range of applications, from metadata, which I'll talk about today, through to things like automating fact-checking within the newsroom to kind of assist journalists and editors. And so metadata is kind of almost like the baseline core piece of NLP that you tend to want to apply when you're in a content-rich business. And so we have this article here. It's about economics. It's about UK politics. It's about Brexit. And that metadata is absolutely critical to the success of us, particularly in a digital age. It helps us build better and new user experiences. So when you have, again, between kind of 250,000 pieces of content over the course of the year, that adds up to millions of pieces of content within your archive. The ability for a user who's kind of short on time to navigate to the content that is meaningful to them is really aided by our ability to put it into collections of topics based on the metadata that sits behind the scenes. Perhaps most importantly, it helps us understand the impact of our publishing decisions. So in an age of free news, where you can read your news anywhere for free, using search engines and other means, our ability to understand what is unique to us that our customers value, what drives engagement, is ever more important. Through doing so, we can reduce churn by producing content that our readers engage and value more, and we can create more relevant advertising. So metadata is not new. We've had metadata tagging on content for years. I guess what's really, really changed is the ability to put that metadata within the same infrastructure as the rest of our data lives to drive better decisions and better user experiences. We've been using Google BigQuery for approximately 6 years now, and Google BigQuery is the home of our customer data, so kind of people who pay and subscribe to the Times. The clickstream, so the behavioral analytics of what happens on our websites and our apps. But then most recently, the actual content itself, so not just the list of content we produce, but the actual kind of full body of the text, the links, or all of the other information. But when you're trying to deal with kind of millions of pieces of content and understanding what is working, what is not working, the metadata is absolutely vital. You can't just rely on the headlines and things like that. And so kind of a really transformative moment was bringing in the metadata within the same data architecture that this other data sits in. Traditionally, keeping your content data in the same database or data warehouse as where your customer data lives would just have been impossible. But BigQuery is an incredibly flexible tool that allows you to do that. And we use Google's AI APIs to derive a lot of this metadata, and I'll talk about a couple of them today. So we'll send the content that lives at rest within BigQuery off to the Google ML APIs, but then send that back into BigQuery itself, so we have this kind of rounded view of the customer, the content, and the behaviors with our digital products. So going back to this article again, so we know it's about kind of Brexit. So Brexit is an entity. It's kind of merged into, it kind of morphed over time into a topic, but it started out as an entity. Things like UK politics, economics, that is a topic. So we're using Google's NLP APIs to kind of systematically, when we produce new content, send it off to the APIs, take it back. We add a bit of kind of business logic and processing on top before surfacing it on the front end of the website. But within BigQuery, we retain all of the kind of the raw data from the APIs for analytics and data scientists to use. But you can only get so far with these kind of, I guess, out-of-the-box entities and topics, types, descriptions of content. As you can probably imagine, we've written hundreds of thousands of articles about UK politics over the years, thousands of articles about Brexit. So how do you kind of distinguish between one article about that same topic and another article over here? And which types of content really drive user engagement and users to understand the value of our product? And so that's where kind of custom kind of metadata comes in, and this is a very recent kind of addition to this to our data architecture. So if you take another article like this, earlier in the year, we employed kind of a team of very skilled interns to look at a sample of our content from the previous year and not tag it based on topics and entities, but using a kind of a much richer classification system, which was developed by a company called Kit in Sweden. And what that led to is, for a given article like this, the ability to kind of get a much deeper understanding of the nature, the tonality of the content. And then when you run analytics on top of this, it gives you a much more kind of nuanced view of the type of content that works well and doesn't work well with our audiences. So rather than being restricted to kind of a broad topic of, I think in this case, kind of music and books, you can get a sense of whether kind of the field reporting style of interviewing, it kind of performs better with certain audiences than other types. But obviously, doing that process once, kind of using, again, some very skilled interns, it is not a sustainable, ongoing process. And we were kind of scratching our heads for a while on how do we kind of like scale this out. So that's where kind of AutoML entered the picture. So AutoML is, again, it's part of kind of Google's suite of ML API products, sitting alongside kind of the natural language API. And what it enabled us to do is, so whilst we have some very talented kind of data scientists in the team who have kind of deep expertise in natural language processing, what this allowed us to do is someone who didn't necessarily have that background to kind of upload this data on the content that had been manually labeled by people within the newsroom, and then train models to try and understand whether we can systematically predict which label new content would have. And so here you see for one of our, so I think overall there were kind of 10 to 20 new kind of custom metadata types within which you'd have kind of 10 or so individual values. So you'd have many dozens of potential metadata tags you'd want to assign. So in this case, we uploaded the content with the tags, and then without having any deep understanding of how NLP approaches work, you can have a look at the performance of the models. And so in a case like this, things like whether the article was deemed authoritarian or objective, the model performed really well. What this then means is that we can kind of systematically tag new content as it comes through and is produced without having to have someone manually label that. As with all these things, there are nuances. So if you're expecting the machine to be able to tell you whether something is funny or not, it is pretty bad. It has like a 4% accuracy rate in terms of determining whether a piece of content is humoristic or not. So it's not a panacea for everything, but it massively advances our ability to apply this much more nuanced metadata to our content on a systematic basis. And so we used AutoML text classification, which really put in the hands of of analysts some of the latest capabilities in natural language processing. The commercial benefits really being us being able to identify exactly the type of content and parts of our journalism that drive the most engagement, supporting acquisition and retention, and so kind of making learnings around kind of what type of content works well in home news, within business, understanding kind of the breadth of content that would interest people, things like world news, understanding that it's actual local, more nuanced reporting rather than informative pieces that work better. Trying to describe metadata around that with traditional approaches would have been very difficult. With this new approach, that starts to become possible. Technical benefits are applying this custom metadata, and it's kind of like a kind of a layered cake. So the AutoML on top of the more fundamental entities and topics using the NLP API, and putting these NLP capabilities into the hands of an analyst. And the real benefit is, and often to kind of, I guess, the skepticism of both myself and also people in the team, is the ability to label with a relatively small number of input data. So traditionally, when you're trying to classify using NLP techniques, you may need thousands of examples of a particular label to assign to a piece of content. In this case, we've had success where you've had as few as 100 or so positive labels for a particular type of metadata. When you're in that world, it reduces the time to do this by hundreds and hundreds of man hours. And what that allows is kind of the people in particular with NLP expertise to focus their problems on other new, more difficult, challenging problems, such as fact-checking with the newsroom. Thank you. So I'll hand back to Levent.
Thank you.
Thank you.
That's fascinating. You got to watch out for this little empty space here. It's easy to fall back. Great. So moving on, last but not least, I want to spend a few minutes on our AI platform. With our AI platform, our goal is simple. We want to provide a robust, reliable, powerful platform for data scientists to create their own models from scratch, to iterate on them, on those models, to do your data science workflows effectively and efficiently. And as part of that, of course, we offer our this end-to-end code-based development environment specifically for AI inside of GCP. It's an integrated tool chain from data labeling to, of course, built-in algorithms to training and prediction. And not only is it integrated within themselves, but of course, it's also seamlessly integrated with the rest of the GCP products, such as Data PubSub, Dataflow, and of course, BigQuery. So again, our goal is to make it as simple as possible for data scientists to create the great models that they're after. Now, one thing I want to briefly touch on is the need for explainable AI. This has been a rising need, especially for our customers in healthcare, in financial services, for many reasons. First, of course, with the rise of deep learning, it is harder to understand why a model is doing what it's doing and why a prediction is happening with multiple layers of neural networks. And the best, of course, benefit is for the data scientists themselves, right, to understand or develop a deeper understanding of their models, to better debug it, to better understand why the model is doing what it's doing. But it doesn't stop there. It actually also helps you communicate the value of that model to other parties within your company and outside of your company. But most importantly, it helps you build user trust, especially if you're predicting things like credit scores or cancer diagnostics. You want to know how the model works, and of course, your customers and users want to be able to trust that model. So to that end, as Google, we're trying to build multiple tools here in this space and have already a few things in place, but there's more exciting news to come on this, so stay tuned for that. I want to now invite Jacob Agris to stage, who's going to talk a little bit more about how they've been using our cloud AI platform within Bayer to help specific use cases around diagnostics. Jacob.
Great. Thank you very much. Wow, a lot of people. Welcome. I'm going to take you through our journey in the use of data in healthcare, and I was asked to speak about AI in healthcare, and I thought, that's huge, AI in healthcare. So I sit in Bayer, which is a pharma company, and you probably know it as the aspirin company, and I want to take you through our journey through data and AI. So first, one of the things Bayer does is radiology, and that sort of got us into this whole arena and field because it's really big data. A lot of them are 3D images, which I'll show you coming up, as well as when we talk about EMR data, which is that metadata. So as we move forwards here, we have a system called Radiometrics, which is our platform that allows us to connect to many different types of data in hospitals. And it's very disparate data, because some of it is metadata, like your EMR, electronic medical record, and other data are images. And often, like if you've ever had a CT scan, I don't know how many people have had a CT or an MRI. A few hands showing up. Those data sets often are 512 by 512 by 512. They're 3D data sets. It's a lot of data. And through our platform, we currently have about, I don't know, give or take a few million, 26 million patients come through it. So you're talking about petabytes of data. Okay? So as we move forwards on this, and I've already mentioned this to you, one, there's on-prem data that we have to digest and understand in order to apply our models. There's the integrity of the data and workflow, because different hospitals have different systems. We have to integrate with a lot of different and non-standardized systems. Data access can be an issue because of these non-standardized systems. And obviously, data security is a big piece of what we do, because in healthcare data, everyone's worried about where their data is and that they want to make sure it's secure. So let me take you through our journey here. So when we wanted to develop an intelligent data lake, we used a combination of some work on Google Cloud with Quantify. And this is sort of how we bring our data sources in. That's our ingestion layer. Then we have a de-identification layer, which you can use. Google has out an API, healthcare API, that allows you to not only ingest different data types, but work on de-identifying that data. Some of the data we do de-identify, the imaging data, through our own proprietary methods. Some of the other data that can be very difficult to de-identify, like doctors' notes. I mean, they can write in their notes, Mr. and Mrs. So-and-so's husband or whatever, and you start to have personal information you need to remove from your data itself, which can be difficult. And then from there, there's our data mart that we then can use to build inference engines and make diagnoses. So as we move forwards here, one of the big pieces of work in any sort of machine learning, unless it's unsupervised, and we're not talking about unsupervised learning here, is the annotation, or that tagging methods, as you all know. So to tag data in healthcare, it's a little different. If you have a self-driving, auto-driving car that you're working on an algorithm for, almost any of us can find the stop signs, even if they're on the right or left side of the road, depending on your US or England. And at the same time, you can find the people in the cars. In healthcare, it's a little more difficult. You need experts to annotate these things. We have a whole platform to allow us to annotate in 3D. Otherwise, it would take forever. I mean, if you had to do 512 images for just one patient, one CT scan, you'd be there forever. Okay? When our data comes in, if we look at, let's say, 50,000 patients, that may turn out to be 2, 3, 4 million images. So you really do need to annotate in 3D. We have technologists annotate first for anatomy, then we have radiologists annotate for the abnormalities, and then we overread. Quality is a huge issue. And it's not so much quality, meaning people annotated it wrong. It's not like a stop sign where I think all of us would agree it is a stop sign or it isn't. In healthcare, there's about a 20% discrepancy between what one doctor says and another, or one radiologist says and another. So there's discrepancies in data because there's different opinions. So all of these are challenges. It's just a quick insight into our annotation platform. There's semi-automatic tools that allow you, and I'm showing you a picture here of the chest and the heart, allow you to segment the ventricles, and then you can by hand correct any of that with a 3D painting tools. And then you can use clipping tools. You're not using scissors along a line here, you're using planes to cut things. So these are how we actually annotate the data. So there's some challenges though, and some of them I've already mentioned. I don't want to take a long time here. We're not trying to turn everyone here into a data scientist in the next half hour. Take maybe 45 minutes. But in healthcare, the data we're looking at from imaging is all 3D. And we're also looking at the EMR data, which is obviously not imaging data. But some of the problems there is people come in all different sizes. You have pediatric patients and tall adults, short adults. So you have many different sized data sets. It's not standardized. And on top of that, they can come with all different resolutions. Each hospital does their own thing. Each doctor may do their own thing. So you have to deal with all these different challenges between disparate data sets. So what do you do about that? Well, some of these data sets are so large they can't be analyzed in one inference. So you have to divide them up like with Kubeflow or something else, and I'll show you examples. But you also have to make, and this is where data science comes in and where physicians come in, some common sense decisions. So some things you want to do, you need full resolution, meaning you need that original 512 by 512 by 512 data set. And there are other things where you can condense that data set down, resample it to like 128 cubed. And you have to know whether your problem allows you to do that. So let me show you an example. So if you look at this example here, and this is where we're using a 3D UNet, as you can see on the left side. On the right, we're looking at a stent, like a cardiac stent. You can see all the little dots of the wires in the stent. At one resolution, you can easily make out that it's got wires in the stent. As the resolution decreases, it certainly turns into like a donut you may have had this morning. And your problem may be good enough to just know it was a donut. And other times, we need to know actually where the wires are in the stent. If you just wanted to measure how big the diameter is of the vessel, the dark part in the middle of the donut, the Dunkin' Donuts donut holes, if that's what you wanted to figure out, the low resolution may be enough. So you have to understand your problem before you can decide what tools to use. That's my point here. So if you need, whoops, I think we went 2 slides ahead there. Yeah. If you need the full resolution, we do use Kubeflow, and that allows you to do your inference on each of the cubes at full resolution rather than resampling it to lower resolution. And on the side here, I'm showing you sometimes we use SqueezeNet on the upper image, and on the lower image, that's DenseNet. And we've used both to make inferences using the Kubeflow engine. The real challenge is once you've implemented this for each of the cubes, how do you put all the cubes together? It's like a flock of birds. Do you need more than 2 cubes to be positive or 3 cubes in order to say that your ML engine should give you an inference or a classifier as positive? And these are some of the questions that come up that tools will and need to be built in the future and some of the things that we work on. So let's just take an example here for, I think again I skipped, yeah, so a case here, lung disease classification. When working on classifying diseases in the lung, again, we need to leverage the AI workspace. We develop radiology solutions to this that use both the EMR data as well as the imaging data, and then we try to classify the pulmonary abnormalities. So as you step forwards, you have to have your image ingestion as well as your other data ingestion. There's pre-processing, there's training, and then there's patient-level aggregation. That's where you have to put the cubes together, and finally, a classification result. And let me show you a little bit better diagram of this. This is one of the key slides in how we approach things, that you bring in disparate data. We have a supervisory AI bot, or like a inference manager, that then manages multiple deep learning algorithms, and each of those looks at different features. Okay? And then the inference engine can decide what AI to run, which of the different modules, and then make a differential diagnosis at the end. And you can have multiple more modules. I'm showing you a cardiac, a pulmonary, a vascular. You could add on other modules for cancer, for breast analysis, and so forth as the system grows. So it's very scalable. I just wanted to show you a few results. Again, after you've annotated or tagged your data, you may want to do like segmentation. A little different than what you've heard about earlier. A lot of that's classification or NLP. Segmentation here allows you, and this is an example of the heart, to look at the ventricles individually, the atria, the aorta, the pulmonary arteries, in order to be able to make diagnoses of like left heart failure, right heart failure, and so forth. So this is one of those engines here built using 3D UNet. And then the other point I want to bring out is, and we're here about AI, and we're here about deep learning, and we do a lot with it, but at least some percentage still requires other algorithms, and we still do a little bit of image processing on the back end in order to then reanalyze these inference outputs. So you saw the segmentation masks. We then can fit these spheres, or in this case, ellipsi, to the ventricles or to the septum to tell you more about how your heart's functioning. So what I want to end with is, what is the future? Imaging and the future of AI in healthcare is very big. It's very broad. There's a lot of people working in it. So imagine a deep learning system where you did have enough data to build kind of whatever you felt like. Now, what if we could make a diagnosis as simple as like a Google search? Or we could eliminate the diagnostic errors. From US data, we know we spend over $3 trillion on healthcare, but almost a third of it we believe is wasted. So these are big things that we can bring to improve healthcare for every individual, not only in this room, but throughout the world. And that's really where we dream about using the different tools we talked about today. So thank you very much.
Thank you so much.
Thank you.
All right. So today you heard from our 3 customers about their use cases. You heard a quick overview of our Cloud AI product portfolio. We have many other customers in EMEA specifically using Cloud AI. Some of them which actually are here today doing sessions, so make sure to check them out. I want us to do a quick shout out to our growing ecosystem of partners. AI journey it can be simple, can be difficult. We want to make sure that there's this growing ecosystem of our partners so that you never feel alone in this journey and you get the help that you need. But may it be integration, may it be other purposes of AI into your workflows. And with that, I want to thank you. Hope you enjoyed our quick overview and our customer stories. I can't wait to see you guys use our tools and hopefully transform your business with AI. Thank you.